Hi, kids. Um, we are gonna learn. At least I'm gonna do just a real quick instructional video about Kepler's three laws. Okay, and I want to make sure you guys understand this should not be something you have to memorize. It's just something you need to understand. First law is just, hey, you know what? When if I have the sun and then I have a planet or a comet or something orbiting around, that the orbit is actually going to be an ellipse, and the sun is going to be at one of the foci points in your ellipse. Okay, just remember though that a circle is actually an ellipse. It's a special one where the two focal points come together at the one single point. So anyway, yeah, that's first one. Second one, and this again should make sense. It should be like that, hey, as I move from here to here, that planet speeds up. Okay, the way it's worded in Kepler's actual second law is that the planet is going to sweep out equal area. So let's say going from here to here is, I don't know, 60 days. Okay, then when it's over here, it would go 60 days, something like this, so that this area and this area are the same. It's going to sweep out equal area in equal time. But essentially what it's saying is that, hey, as it goes closer to the sun, it's going to speed up. So yeah, okay. That's the second one. And then the third one is the one that people always try to memorize, and they're like, is it r cubed over t squared? Is it t cubed over r squared? What is it? And I want to show you guys you don't have to memorize it, okay? In fact, I would prefer for you not to memorize it, because if you just remember this, okay, remember an ellipse is a special circle, so that if we pretend for a second that my orbit is a circle, well, at this point, for example, if I draw the forces acting on it, I only have the force of gravity acting on it. That's a little Fg, if you can't see. So then if I write my equation, I get Fg equals Fc. Why? Because it's a special net force that's causing it to move in a circle. Because I am talking about the universal law, I get this, gmm over r squared equals mv squared over r. I can cancel out my m. What m did I just cancel out? I canceled out the mass of this planet. Okay, I can cancel out one of the r's. So now I have gm, where this is the mass of my sun in this case, r, which is the average radius here, divided by the linear, and then equals the linear speed squared. Well, if this is moving in a circle, it's not speeding up or slowing down, because it's not getting closer or farther. So that means it's moving at a constant speed. If something moves at a constant speed, what equation you use? You use v equals d over t. Well, what is the d around the circle? 2 pi r. What is the time around the circle? The period. So if I plug stuff in, I'm going to get gm over r equals 2 pi r over t, this whole quantity squared. And hopefully you can already see, oh look, it's going to be r cubed over t squared. See, la 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 la. But anyway, let's just finish it. This is going to end up being gm over r equals 4 pi squared r squared over t squared. And then if I cross multiply, and I'm going to erase so I can do it over here. If I cross multiply, gm over 4 pi squared equals r cubed over t squared. Okay, so that what Kepler's third law is saying is that this ratio is going to be a constant. And if you, again, guys, if you do this process will take you all of, I don't know, like 2 minutes maybe. The only force acting is gravity, so set it up, and then, oh look, it's this. You will always get it right. If you try to memorize it, and your chances are you're gonna, during the stress of the test, it's like, what do I better remember? Well, just take your time. Boom, there it is. Okay, but remember then how you can use this to solve things. That this times this over this is all going to be a constant, which is why this is a constant. But then if we decide to change our units around, which to make things easy, if we use 1/8 AU, which is the distance, the average distance from the sun to the earth, as our R value, and then we use 1 Earth year as our time, then that means that R cubed over T squared is going to equal 1. Okay, now it is 1, the units are a little weird, AU cubed over years squared, but it's 1, which is a really nice number, 1, which means we can do things like, hey, there's some random asteroid orbiting the sun, and the average distance that asteroid is from the sun is 4 times the Earth's distance from the sun. So you would say, hey, you know what? This is going to be 4 cubed over T squared. Well, that equals 1. And then I can solve that for T. And lo and behold, you can solve for things. Hooray! But yeah, it should be really easy once you guys get to there. So I hope that helps. Bye, kids!